Here's how to use the complex conjugates theorem to write a polynomial function of least degree with integral coefficients having the given zeros. What? Well, here we go. We're going to do exactly that. But let's go ahead and break down what it is we're even looking at. So first of all, it says write a polynomial function. Well, that just means to write any polynomial. So, x squared plus 2x plus 5. That's a polynomial. Then it says of least degree. So basically we need to write the least complicated polynomial we can. Degree in this case means the biggest exponent. So for example, if we were to write an equation with x to the 72 plus da 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 da, but we could write the same thing with x to the any lower number, then we did it wrong. We have to get the lowest number possible. Then it says with integer coefficients, which basically just means we can't have decimals or fractions, which honestly makes our lives easier. And then finally, it says it needs to have the given zeros, which are these. Now, how do we use these zeros to our advantage? Well, for that, we're basically going to think of something like factoring, but the opposite way. If you know about factoring, you may know that when you factor an equation, like for example, if we had x squared plus 5x plus 6, if you were to factor this, and I won't go through the whole thing, but if you were to factor it, you would factor it into x plus 2 times x plus 3. And then you would split these up, and from there you would get two zeros. Zeros are basically just a fancy way of saying your answers. But we can actually think of this the opposite way. If we have our zeros, we can turn them back into these little equation things here, these little polynomials. But I did talk about something called the Complex Conjugates Theorem, which is just my favorite rule to say. The Complex Conjugates Theorem says that if you have any zero that's part real and part imaginary, that's where the word complex comes from. Complex means part real, part imaginary. Like this one here. This one has a real part, which is 3, and it has an imaginary part, which is I. It says that if you have a part real, part imaginary zero, then it's going to have the same zero, but with the sign changed. So if it has 3 plus I as a zero, it must also have 3 minus I as a zero. This is required. You can't have one and not the other. So we know that these are the 3 zeros that our polynomial function of least degree with integer coefficients must have. So we're going to work backwards and take these zeros that we already have and turn them into those little factored parenthesis things. So for example, we have 4 here. We always do the opposite sign. So this is going to be x minus 4. And the reason for that is if you were to split these up and turn this into x minus 4 equals 0, then if you added 4 to both sides, you would get x equals positive 4. So we can do the same things for these. Even though they're a little bit complicated, we can have x minus 3 plus I. And it's important that we put this in parentheses because the minus sign applies to both of them. Well, you'll see why in a second. And then this is going to be times x minus 3 minus I. So what I'm going to do is I'm going to distribute the minus sign to both the 3 and the positive I in this case, and then to the 3 and the negative I in this case. Because remember, a minus and then something in parentheses means distributive property. You have to distribute to both. So we're going to have minus to the 3 and minus to the I. So we're going to have x minus 3 minus I. And then over here, we're going to distribute the minus sign as well. So x minus 3 and minus negative I. So we're going to have x minus 3 and then minus minus I. 2 negatives make a positive, so that's going to be plus I. And now here's where a lot of people get stuck. It seems like what am I going to do here? And you could just multiply all this out, and it would take a really long time. But I'm going to show you a little shortcut. So for this, you're just going to kind of have to trust the process and see why I'm doing this in a second. But I'm going to put parentheses around x minus 3 on both of these. We're going to leave x minus 4, and we're going to do FOIL on this first. So remember that for FOIL, you have to follow the steps of FOIL. So the first step of FOIL is f, which is first. So we need to multiply the first parts of both of the parentheses. In this case, x minus 3, I put parentheses around it because we're treating it as one thing. So we have x minus 3 times x minus 3. We don't have to multiply that right now, actually. We can just leave it as x minus 3 squared, because squared just means multiplying it twice. Next, we have outer, which is O. So we need to multiply the outer parts. So we're going to have x minus 3 times I. I don't really feel like multiplying x minus 3 times I, so I'm just going to leave it as I times x minus 3. And you'll see why I'm doing that in a second. Then we need to multiply the inner, which is I. So that's going to be minus I times x minus 3. Remember that minus signs always stay. So this is going to be minus I times x minus 3. I'm not going to bother multiplying it just like before. And then finally we have L, which is for last. So we have minus I times plus I. I times I is I squared. And then we have one minus sign. So the minus sign stays. So you might think that we've made this more complicated than before. But I'm going to show you why we put parentheses around x minus 3. It's so that we could get this. Do you see what's special about this? We're adding I times x minus 3, and then we're just subtracting the same thing again. If you add something and then just subtract it again, you've done absolutely nothing. So this actually all cancels out. We don't even have to multiply this together. So the x minus 4 is going to stay just like before. And then we're going to have x minus 3 squared minus I squared. And see, this is now simpler than before. Now, this may still be a little bit confusing because we do still have i's in here, but remember that I squared is actually special. Now, if you're not quite familiar with imaginary numbers, I do have a full video on it that you can watch on the card on the screen right now. But the thing you need to know is that I is the same thing as the square root of -1. But this is I squared. So we have the square root of -1 squared. But you may also realize that a square root and a squared do the exact opposite things. So these actually cancel out, and all we have left with is -1, which is a real number. So everything else is going to stay the same. And then we're going to have negative I squared is now -1. So -1. We have two negatives here. That makes positive. So we're going to have +1. So now we've gotten rid of all the i's. We don't have any more imaginary stuff. It's all real. So we can just simplify this. So the first thing to simplify is probably the x minus 3 squared. Remember that squared means you're multiplying it by itself. So x minus 3 squared is the same as x minus 3 times x minus 3. And for this, we can use FOIL again. So we're going to do first. The first step means to multiply the first parts. So x times x is x squared. Then outer, so we need to multiply the outer parts. So that's x times, not 3, -3. Remember, minus signs stay. We can't multiply a number and a letter, so we're just going to leave it as 3 times x. Then we have inner, so we multiply the inside parts. That's -3 times x, which just like before is just -3x. And then finally we have last, so we're multiplying the last parts. That's -3 times -3. 3 times 3 is 9. And then we have two negatives. Two negatives make a positive. And then these we can just combine, because you can combine like terms. That's the fancy name for this. So we have x squared minus 3x minus another 3x. That's a total of minus 6x. And then plus 9. So instead of x minus 3 squared, we're going to put what we just solved here. X squared minus 6x plus 9. But then don't forget this plus 1 here. We also have a plus 1 here. And we can combine these. This is just 9 plus 1, which is 10. So we're going to replace that with 10. So there you go. We've done FOIL on this, and all we have left to do is multiply these two together. So the way I like to do this is to do them as two individual problems and stack them. So we need to do distributive property with the x. So we need to multiply the x to all three of these. And then we need to do the same thing with the -4. We need to multiply the -4 to all three of these. So let's do it with the x first. X times x squared, well, that's 2x's times another one. That's a total of 3. So we're going to have x to the third. Then we're multiplying x times minus 6x. That's just adding on another x. So it's going to be minus 6x squared. And then we're multiplying the x to the 10. You can't multiply a number and a letter, so it just stays by itself. 10 times x. Now we're going to multiply the, remember, not the 4, the minus 4 to all three of these. And I'm going to do it on the line below. So -4 times x squared, you can't multiply those, so it just stays the same. -4 times x squared. And I'm going to lay it under this other x squared. Then we do the -4 times the minus 6x. 4 times 6 is 24. We have two negatives. Two negatives make a positive. And then we have an x, so the x stays. And then finally, -4 times 10. 4 times 10 is 40, and one negative sign, so the negative sign stays. So now all we have to do is add these two together to get our final answer. So x to the third, that's just by itself, so x to the third. Then we have minus 6x squared minus 4x squared. We can think of this as dollars. We lost $6, then lost another $4, so we're down $10. Then we have 10x plus 24x, 10 plus 24 you could put in your calculator if you wanted to, 34x. And then this minus 40 is by itself, so it stays as minus 40. So this right here is our polynomial function of least degree with integer coefficients and the given zeros. So this is our final answer. So you now know how to use the complex conjugates theorem to find the polynomial. I'm not going to say that. But you may have noticed that what we've been doing is basically just the opposite of factoring. So if you want to learn the 5 main ways to factor, you can watch this video right here. And of course, if you have any questions about using the complex conjugates, then you can leave a comment and I'll be sure to answer your question. Thanks for watching.